Good morning, students. And in this section we will discuss about primary and secondary constants. An important topic here, simply primary constants. These primary constants are nothing but what are the elements those are existed with the transmission line. In our previous classes, while discussing to the basic transmission line, we have already discussed regarding to basic elements associated with the transmission lines. Those are resistance, inductance, capacitance and conductance. These four are called as primary constants. Primary constants. Those four are called as primary constants. While coming to the secondary constants, the secondary constants are the first one is Z0, that is characteristic impedance. Characteristic impedance. We have already derived the expression for characteristic impedance. That is simply Z0 equal to square root of R plus J omega L by G plus J omega C. It is the one of the secondary constants. And at the same time, the another secondary constant is gamma. Gamma is nothing but propagation constant. Propagation constant. And we have already derived the expression for gamma. That is gamma equal to square root of R plus J omega L into G plus J omega C. It is the expression for propagation constant. And now this gamma can be written as alpha plus J beta. Alpha plus J beta. That is gamma. Here alpha is nothing but attenuation constant. Alpha is nothing but attenuation constant. Attenuation constant. Simply this attenuation constant is nothing but the real part of the propagation constant gamma. Simply attenuation constant is the real part in propagation constant gamma. And at the same time it will describes about how voltage and currents are reduced along the transmission line. This attenuation constant describes us how voltage and currents are reduced along transmission line. That is attenuation constant. And the units for the attenuation constants are Nepers per meters. Nepers per meters. And similarly beta. Beta is nothing but phase constant. Phase constant. Phase constant. Simply this beta is nothing but the imaginary part in the propagation constant. Imaginary part in the propagation constant. That is beta. And this beta describes us how the phase position of voltage and currents along the transmission line. That is phase positions of voltage and currents along transmission line. That will describe this beta. And the units for beta are radians per meters. Radians per meters. And these are the few points regarding to primary and secondary constants. Along with this, we have to discuss regarding to two parameters. One is phase velocity, and another one is group velocity. First we will discuss phase velocity. It will be represented as V suffix P. Phase velocity is nothing but V suffix P. Simply it is defined as the velocity with which the single signal of frequency propagate along the transmission line. Simply, phase velocity is defined as the velocity with which single frequency signal. That means simply the single frequency signal velocity will be used by phase velocity, that is V suffix P, and it can be given as V suffix P equal to omega by beta radians per seconds. That is the expression for phase velocity. And similarly another point is group velocity. It will be represented as V suffix G. Group velocity, and here this group velocity defines the wave contains different frequency components which are travel at different velocities, but the envelope of voltage will be gives us group velocity. That means here it is the group of signals. Here phase velocity is for single frequency signal, and here it is group velocity for group of signals for different frequencies, and it will be given as V suffix G equal to dou omega by dou beta. Here it is omega by beta, here it is dou omega by dou beta radians per seconds. This is regarding to primary and secondary constants.